Hello and welcome to this Microsoft Meets community event. My name is Ryan Mangan and it's a pleasure to be presenting to you today. First of all, I'd like to thank the teams at Microsoft and Christian Brinkoff for preparing this event. Windows Virtual Desktop is one of the most popular topics within the industry today because of its flexibility as a solution and the Windows 10 multi-session experience we can all enjoy. I'll be walking you through this presentation on disaster recovery and business continuity for Windows Virtual Desktop. Before we get started, let's look at the contents of this presentation. First of all, we'll introduce disaster recovery and business continuity for Windows Virtual Desktop. We'll then take a look at networking, virtual machines, managing identities, shared image galleries, FSLogix profile containers, and MSIX app attach. I will then finish off with a summary. This presentation includes around 50% slides and 50% demos. I do hope you enjoy. So let's get started. Before we start, let me introduce myself. I've been in the IT industry for 15 plus years and specialise in virtualisation and end-user computing. I work for AppCure, who specialise in parsing applications from legacy operating systems and migrating them to Windows Virtual Desktop. I'm the owner and author of RyanMangansITblog.com, where I've produced over 200 plus articles on remote desktop services and Windows Virtual Desktop. I also wrote Microsoft's Quick Start Guide for Windows Virtual Desktop, and I've just finished a new book on an introduction to MSIX app attach. You can find the links for these books on my blog site. So I wanted to cover off RPO and RTO before we take a look at traditional versus cloud disaster recovery options. Recovery Point Objective, RPO, is a measure of how frequently you take backups. If a disaster occurs between backups, can you afford to lose 5 minutes worth of data? Or 5 hours? Or a full day? RPO represents how fresh recovered data will be. In practice, the RPO indicates the amount of data updated or created that will be lost or needs to be re-entered after an outage. Recovery Time Objective is the amount of downtime a business can tolerate. In a high-frequency transactional environment, seconds of being offline can represent thousands of pounds in lost revenue, while other systems, which are not so important, can be down for hours without adversely impacting the business. The RTO answers the question, how long can it take for our system to recover after we were notified of a business disruption? A question to the audience, what does it mean to your business if you suffer an outage? So let's take a look at traditional versus cloud. Traditional VDI solutions can be expensive. You need to factor the setup and upfront investments you require to make for the hardware, software, and the daily running costs, including electricity and cooling. When you look at on-premise solutions, you need to also take care of the physical hardware, physical networking, and the configuration and support for potentially multiple locations. Carrying out disaster recovery testing may require you to travel to multiple locations, which could be challenging. What about connectivity issues? Issues trying to connect to a physical location. How do we gain access to that data or services if connectivity issues occur? Cloud offerings remove the physical layer when it comes to disaster recovery. You can essentially manage everything from a single pane of glass, removing travel, physical hardware replacements, as well as the introduction to a new concept of pay as you consume. So let's take a look at Microsoft Azure as a cloud provider. There are 54 plus data centers across multiple geographical regions. They are typically 100 miles apart from each other, reducing the potential of multiple data centers being impacted by the same issue. Access to Microsoft Cloud services from over 140 countries. The ability to access cloud resources from so many geographical locations. Change the way you bill. Improve the way you project and manage costs. Cloud offers a consumption model where you only pay for the resources you consume. Whereas physical, you have to pay for an upfront capital investment. Typically, you may be leasing, but still, there is a total value of that hardware. Connect to Microsoft Cloud, on-premises, a single device, or multi-cloud. There are many options and scenarios available to you. What does this mean for Windows Virtual Desktop? Well, that's a good question. Take full advantage of Microsoft's cloud core infrastructure. It's fast and it's designed to scale. Multiple regions accessible using a common web browser. You can access your resources on many device types. Could be a mobile phone, could be a laptop, could be a tablet. You can still access the resources. Take advantage of a highly available, multi-region supported Windows 10 multi-session desktop offering. This is exclusively for Windows Virtual Desktop on Microsoft Azure. This essentially allows you to enjoy a Windows 10 experience across multiple regions. And there's no more worrying about physical hardware anymore. This is taken care of by Microsoft. So here is a resource which may be useful for you. It allows you to quickly identify the nearest data center to you. You'll also note that it provides a latency reading for each data center. So that's azurespeedtest.azurewebsites.net. I have also provided you a quick video showing the output. There you have it. Let's now take a look at an overview of Windows Virtual Desktop in the terms of disaster recovery and business continuity. As we know, session hosts are virtual machines. These can be replicated between regions using Azure Site Recovery, also known as ASR. You may also consider running standby virtual machines under the same or different host pool. Provide access to FSLogix profile containers from a second region, facilitating access to profile containers. Take care of user identities, typically domain controllers, ensuring they are accessible in the second region. If session hosts are in the second region and there's no communication available to a domain controller, you will not be able to log on. And finally, ensuring access to line of business applications, ensuring they're accessible from this secondary region. As a final note on the introduction to this presentation, I did want to cover reserved instances. These may be useful for services you may wish to run continually in a second region, like a domain controller or a hot standby session host. So a pay-as-you-go model may not be suitable for these type of services. Thus, using reserved instances may offer a reduction in cost. It is also important to note, if there are resource capacity restrictions within a region, by using a reserved instance, you would not be impacted by these potential restrictions. We now move on to network considerations for disaster recovery. In this section, we'll cover VNets, Azure Site Recovery, DNS, Network Virtual Appliances, also referred to as MVAs, peering, and some options available to you for ensuring connectivity to domain controllers from a network perspective. So you want to create a disaster recovery solution for your Windows Virtual Desktop environment. Okay, here are some network pointers to write down. You need to ensure that a VNet is set up in a second region. This can be done manually or it can be taken care of by ASR, Azure Site Recovery. For organizations who need access to on-premise resources, you will need to ensure that a VNet can access them. This can be done using a VPN, a network virtual appliance, an express route, or a virtual WAN. An important point to note here is Azure Site Recovery is the recommended solution for VNets in a failover region, as it takes care of or preserves your primary network settings, whereas peering does not. We will cover peering shortly. So, as always, DNS. DNS is an important part to enable communication between the resources. So you need to ensure that the DNS settings are correct between the two regions. If you are setting up a VNet in a secondary region manually, you need to ensure that you still can have access to the domain controller via DNS. Whereas if you're using ASR, this is taken care for you. When using network virtual appliances, you need to ensure that you have included the correct rules and exceptions for Windows Virtual Desktop. You can find this information by searching online for Getting Started with Windows Virtual Desktop, or referring to the ebook I created for Microsoft, A Quick Start Guide to Windows Virtual Desktop. Virtual network peering enables you to seamlessly connect two or more virtual networks in Azure. The virtual networks appear as one for connectivity purposes. The traffic between virtual networks in peered virtual networks uses Microsoft's backbone infrastructure. Like traffic between virtual machines in the same network, traffic is routed through Microsoft's private network only. Microsoft Azure supports the following types of peering. Virtual network peering. This enables you to connect virtual networks within the same Azure region. And then you've also got global virtual network peering, connecting virtual networks across Azure regions. And some of the benefits of using Azure virtual network peering, whether local or global, include low latency, high bandwidth connections between resources within the different regions. I should say different virtual networks. The ability for resources in one virtual network to communicate with resources in a different virtual network. The ability to transfer data between virtual networks across multiple Azure subscriptions, Azure Active Directory tenants, deployment models, and Azure regions. The ability to peer networks created through the Azure Resource Manager, and also the ability to peer virtual networks created through the Resource Manager to one created through the classic deployment model. Also, there's no downtime to resources in either virtual network when creating the peering or after the peering is created. We now take a look at the networking associated with domain controllers in Azure. The first example shows you the replication of a domain controller from a region A, which is the primary region, to the secondary region, which is annotated as B. When setting up Azure Site Recovery for the first time, it will copy the network settings and replicate them to the second region. This includes DNS settings of the network, IP range and gateway. What this means for a failover perspective is you have less to worry about. You simply complete the failover and test once completed. There are no IP changes or network reconfiguration, as ASR is copying the primary region's VNet. The second example shows an on-premise domain controller connected to regions A and regions B. As you can see from the diagram shown, we have a primary region annotated as A, which has ASR configured to region B. We also have an on-premise VPN connection from region A and region B, which facilitates the communication of an on-premises domain controller. Point to note, if you have an on-premises VPN, you may want to configure the second region's VNet and set up the VPN to speed up the process when carrying out a failover. In the next section, we're going to look at virtual machines, so looking at replicating them between multiple regions, specifically the session hosts. So turning to virtual machine options, you can configure all your virtual machines for both pooled and personal host pools within Azure Site Recovery. With this method, you only need to set up one host pool and its related app groups and workspaces. You can create new host pools in the failover region while keeping all resources in your failover location turned off. For this method, you need to set up new app groups and workspaces in the failover region. You can then use an Azure Site Recovery plan to turn host pools on. You can create a host pool that's populated by VMs built in both primary and failover regions while keeping the virtual machines in the failover region turned off. In this case, you only need to set up one host pool and its related app groups and workspaces. You can use Azure Site Recovery Plan to power on host pools with this method. So before you carry out a failover or do anything in a disaster recovery situation, you need to ensure that all of your users are logged out of the primary Windows Virtual Desktop host pools. So before you fail over to the secondary. Once all users are signed out, you can then go ahead and fail over to the secondary region. How do we do that? Well, with classic WVD, we can use the invoke RDS user session logoff, and then with the new improved Azure integrated version, you can use remove-az WVD user session. Naturally, you won't want to do that for 1,000 users. You will need to use the PowerShell or other automation tools available to you to kind of speed up that process and simplify that. So without further ado, we now move on to the demo, the first demo of this. So first of all, recovery service vaults. We're going to create a recovery service vault. We're going to select Microsoft Meet Event Resource Group, and we're going to set the vault name to ASR WVD. And we're going to create that in the target location, which will be the secondary UK West. We would not create that in the primary, because if there's an issue, we can't recover. So recovery vaults are always created in the opposite side. Once that's created, you're going to click Enable Site Recovery and then Enable Replication, as you can see there. Select the source region, which is UK South. Then we select the resource group again. You'll also note you can choose between availability zones. In this case, we're not using them, so we'll just disable that. And then we select WVD pooled 1 and 2, or 0 and 1 even. And then we go forth to proceed with enabling replication. So now we need to just check that all the settings are correct and as required, and they pretty much look fine to me. Just double check the networking and the storage. And then we go ahead and enable the replication once you're happy with the settings. So what I'm going to show you now is just a quick way of replicating the domain controller using ASR. So if you go into the domain controller settings and scroll down to disaster recovery, and then select the target region, which is UK West, it should pick up the previously configured settings from when we did the session hosts. And then we're going to go off and start the replication process for the domain controller. Because as I said previously, if we don't have a domain controller at the second region and we can't communicate with identities, we're not going to be able to log on. So just wait for this to finish, and then we can proceed with looking at some of the host syncing settings, and then we'll look at DC failover and the session host failover itself. So just having a quick look now, here's our recovery vault. We scroll down to site recovery jobs, and as you can see there, we can now see that replication has been enabled and things are working correctly. If there's any concerns or issues, they'll be marked red, and you can then go check out what the issues are and fix them. And now you can see there that the WVD pooled resources are replicating. And there's also the orange, I won't worry too much, that's a test failover. For the purpose of this demo, we're not too worried about that. So we're just waiting for this final sync to be complete before we can do a test failover. So before we do that, let's go and failover the test domain controller. And now we just wait for that to complete. So that's now failing over the domain controller to the second region, which is UK West. So we're taking it from UK South to UK West. As you can see, it's starting the failover process, and there is 5 steps listed there. And there you have it, completed. And then we go and check. And you can see that the failover has now been completed. So let's go now and failover the session hosts. Same process, click failover, and that will then follow through the wizard again. As you can see, there's 2 screens on this one, where we basically have the desktop on the left hand side and the Azure ports on the right. Because what we're going to do is we're going to show you the failover in process. So I'm just going to start that failover now. Okay, and again, failover jobs, they've now completed. Just checking. And we're now going to fail over the second one. So we're doing these manually one by one. Again, this is a lab, so don't worry about that. Go through and start the failover process. And you can see the 5 steps. It's going through and now it's completed. And then you can see that these VMs which are running are now in the UK West and not the UK South. So the final part of this demo is to show you that we can now connect to the session host after being failed over using Azure Site Recovery. It's important to note that the session host agent communicates back to the WVD management plane, so there's nothing for you to do. It's taken care of by Microsoft. Once the desktop is loaded, we can then use the command prompt to identify the session host and check to confirm this is the same session host running in the UK West after failing over from the UK South. So just finishing off, waiting for this to finish off loading so we can actually bring up the command prompt. And we should be ready now. And there you have it. And this concludes this demonstration. So we now move on to the topic of managing identities, specifically around domain controllers and Active Directory. As we've just covered the domain controller of replicating and failing over in the previous demo, what I wanted to do now is just tidy up on some of that and go into a little bit more detail. So with most things related to Windows Virtual Desktop, you need a domain controller. Without one, you're unable to communicate to different services on a particular network. And the other important thing here as well to remember is that to deploy new session hosts and to be able to log into a session host, you need to be able to have access to an Active Directory domain controller. So without that, you would not be able to communicate, thus not being able to access WVD resources. So here are some of the scenarios and ways of deploying Active Directories available to you today with Windows Virtual Desktop. So first of all, you can have an Active Directory domain controller in a second location. So that means you could deploy one and leave it running, continually updating between different sites. You can link an on-premises Active Directory domain controller using VPN or an express route. Or you could just replicate an Active Directory domain controller using Azure Site Recovery, ASR, as you've seen in the previous demo. So the diagram you can see on the screen is two Azure regions connecting to an on-premises domain controller. One of the challenges with that is if there is a communications issue or a network failure with the on-premises side, that could be quite problematic for Windows Virtual Desktop, as in users will not be able to log in. So when it comes to designing and planning your Windows Virtual Desktop environment, you need to understand what risks are associated with the particular design. So if you put a domain controller in Azure and a domain controller on premises and connected to the domain controller via VPN, if there was an outage or a complication with on-premises, your WVD users would still be able to connect because the domain controller what resides within the Azure region is still functioning correctly. And when that communication is restored on the on-premises side to Azure, then the updates and communication between the domain controllers will be resynchronized. So some of the options available to you. Use ASR replication for your domain controllers between the primary and failover regions. As you saw in the demonstration I previously showed, where we basically took a domain controller, we enabled disaster recovery and failed it over to the second region from UK South to UK West. And then we were able to fail over the session hosts and connect and access Windows Virtual Desktop. Another option to you is to deploy a domain controller to your failover region, ensuring that you have communication and connectivity back to either on-premises or to region A so that the domain controllers are communicating with each other and keeping up to date. And then the third option is link your second region back to on-premises. So if you are failing over between the two regions, both regions have access to on-premises. However, as I said previously, you do need to ensure what happens if the connection between on-premises and Microsoft Azure fails. What does that mean for your WVD users? We are now going to move on to the next part of this presentation, where we're going to talk about shared image galleries, also known as SIG. Point to note, shared image galleries recently became generally available from preview. So shared image gallery is a service that helps you build structure and organization around your operating system images. Simple as that, really. Shared image galleries provide the following key features and functions. So these are quite important. The first one I'm going to kind of cover is global replication of images. This is obviously quite important from a disaster recovery perspective if you want to spin up in multiple regions from the same image version. Version and grouping of images for easy management, and high available images with zone redundant storage. Then you've also got things like premium storage support for premium LRS, and sharing across subscriptions and even between Active Directory tenants using RBAC. Scaling your deployments with image replicas in each region. Using a shared image gallery, you can share your images to different users, service principals, AD groups within your organization. Shared images can be replicated to multiple regions for quicker scaling for your deployments. And image, so let me just cover off an image as well. An image is a copy of either a full VM, which includes any detached data disks, or just the operating system disk, depending on how it's been created. When you create a VM from an image, a copy of the VHDs in the image are also used to create the disks for the new VM, like a snapshot, I suppose. The image remains in the storage and can be used over and over again to create the new VMs, which we need to do if we're going to deploy WVD out to multiple regions. So let's summarize shared image galleries for disaster recovery and business continuity for Windows Virtual Desktop. So replication of Windows 10 images from the primary region to multiple other regions. Offer global replication of images for easy management, and standardize your image globally from a single source. And that brings us on nicely to the next part, where I'm going to give you a demo of creating a shared image gallery image and replicating that between two regions. Okay, so here we have a WVD template I previously created, and what I'm going to go do now is capture that. And within the capture section, it allows you to choose a gallery as an image version or just a managed image. In this case, we're going to go and fill out the shared image gallery name, and I'm going to call it RMIT blog. And then I'm going to leave it as generalized from an operating system state. And then I'm going to give it an image definition name. So again, RMIT blog. A version number. As you'll note, you've got to do the dots. And then I'm going to choose the target replication. So as you can see here, I'm going to replicate UK West from the UK South. And you can add multiple different regions if you wanted. So UK South and UK West there. Then now we're happy with that, move on. Move on to the next. So check all the bits and bats. Make sure you've configured how you like them, and then click create. So what will happen now is this will go ahead and create a shared image in a shared image gallery, which we've just specified. So if you haven't got a shared image gallery in the starting point, you can basically do that through a simple capture button within the VM portal page, which makes it nice and simple. So as you can see here, the deployment's in progress. It successfully generalized the virtual machine. And then we can go to the resource, and there you have it. We now have a shared image gallery right in RMIT blog, and within there we have our image. And then as you can see as well, it's replicating between UK South and UK West. So we now move on to FSLogix profile containers within Windows Virtual Desktop for disaster recovery and business continuity. So before we talk about what you can and can't do, I just wanted to put some context for people who may not know what FSLogix profile container is. So essentially, an FSLogix profile container is a user profile disk which resides in a remote location like Azure Files or a network share. When the user logs on, that profile disk is attached, and the operating system sees that disk as the location to store user data. So some of the options available to you when storing your FSLogix profile containers could be storage spaces direct, a network drive, or a virtual machine with multiple drives attached to that, Azure files, Azure NetApp files, and then also Cloud Cache for replication, which we're going to cover in a technical demo within this presentation. Now let's take a look at the different options available to you for copying user profiles between locations in the same region or between multiple different regions. One example is to use a copy script. The challenge with this is copying profiles that are in session, brackets locked. You also need to be aware that you would need to run these scripts repeatedly throughout a day to ensure there is a low recovery point objective. Otherwise, in the event of a failover, user profile data may be missing as you have failed over using an older or previous day's user profile. So any work that the user may have completed is now obsolete because they've created new work which they've now lost. And then the other thing is, if you're running these scripts repeatedly throughout the day and there is lots of data, then there may be an impact to network performance which is associated to copying all of this profile data. So we're now briefly going to cover Azure NetApp files. So for those who are not too familiar with Azure NetApp files, Azure NetApp files offers a managed storage solution for Windows Virtual Desktop and FSLogix profiles. It offers low latency and high amount of IOPS, which is great for those deploying at enterprise level and at large scale. It provides up to 450,000 IOPS at a sub-millisecond latency, capable of supporting incredibly large deployments of Windows Virtual Desktop. Azure NetApp Files also offers cross-regional replication. This disaster recovery capability, which it is, allows you to replicate your NetApp file volumes from one region to another. You can also create space-efficient point-in-time volume snapshots, impacting volume performance. So this capability allows you to roll back individual FSLogix user profile containers if there is an issue. So another way you can store FSLogix profile containers is using storage spaces direct, also known as S2D, which essentially lets you host a guest cluster on Microsoft Azure, which is especially useful for things like FSLogix profile containers. One of the big benefits here as well is using ASR, Azure Site Recovery, to replicate their S2D between multiple different regions, allowing you to protect your profile containers as you cross regions on failover. The other option you have as well is network drives. You could have a virtual machine with multiple drives assigned and use that to store the FSLogix profile containers. Ideally, that would be a very small user environment, and you can also replicate that using Azure Site Recovery. FSLogix Cloud Cache is a good option for Windows Virtual Desktop disaster recovery. In summary, it works by storing a cached version of the user profile in the program data folder of the session host. It's important to note that FSLogix Cloud Cache does not improve user sign-in and sign-out experience when using poor performing storage. It's important that you spec your storage correctly to avoid any performance impact. However, it is suggested that any performance impact should be considered, as the benefit is to access user profiles across multiple regions. It's common for environments using Cloud Cache to have slightly slower login, logout, or sign-in, sign-out relative to using traditional VHD locations using the same storage. After the initial sign-in, the Cloud Cache can improve the user experience for subsequent reads of data from the profile container, as these reads are serviced from the local cache file. It is advised that you spec the session host correctly when deploying Cloud Cache to prevent any poor performance by users. So this brings me now onto the Cloud Cache demo. So what you can see in a second is that we have two screens. On the left hand side we have a desktop, and on the right hand side we have an Azure blade showing Azure files and the file share called FSLogix. When we log in, we're logging in for the first time. So what this will do, as per the demonstration, will show you the FSLogix profile container appear in a folder, and then as you can see, profile underscore test user.vhdx. So what will happen now is the desktop will go ahead and create that profile and log the user in, and we just need to wait for that to complete. So once we're logged in to the session, we'll then open up the registry. And when we've opened up the registry, you'll see within the FSLogix section, FSLogix and profiles, you'll see VHD locations. And you'll note that two are set. One being Azure files, and the second being, for lab purposes, the domain controller, which I've created a file share, as you can see there. So then what I'll do is I'm just going to go into to the program files and go to the FSLogix folder, and you'll see a tool which is quite useful, configuration tool. It's quite useful for doing quick tests and quick setups for FSLogix, and you can see that the two are specified as set in there. So what I'm going to do now is I'm going to go and restore the registry for Cloud Cache so we can speed up the demo, so we're not here all day. So I'm just going to, here's one I made earlier, a reg key, which basically just restores all the settings required for Cloud Cache, which is essentially the CCD location. So I'm just going to open up registry again now. And then what you can see is I've got VHD locations and CCD locations. And in there the string's slightly different, but it's specifying both the Azure files location and the secondary location, which is the DC. We then delete the VHD locations. Then we sign out. We don't need to reboot or restart, we just sign out of the session and then re-establish a new session from sign in. Just wait for that to finish doing what it's doing, and then we run a new session. So we're signing in again, and now what will happen is we should see a different background because it's taking the Cloud Cache from the secondary location and pulled that in. So give it a minute. Again, you'll note it is slightly slower. There you go. So what we have now is a session using Cloud Cache, and that is between the two. So we've got the local DC share and we've got the Azure files as well. So what we're going to do now is just go into the registry, software, FSLogix, profiles, and as you can see, it is the configuration CCD location is what it's using for Cloud Cache. So then what we do is that we then go to disk management, and you'll see the FSLogix profile container attached. And there you have it, it says profile-test user. So we now know that it's using FSLogix profiles attached, and now we just need to check where the whether the cache is working. And as you can see, program data, we now have a user using the cache, and what you'll see in here is like different files and things appear here and there because it's caching. There you go, see? And there you have it. We're using FSLogix Cloud Cache, and like I said, there's two strings, so there's the first string. We're going to take that, and I'm just going to show you in both the shares so that you can see the profile is in one. And then just to double check, we're going to go to the location 2, which is the DC, if I can type properly. And there you go, it's there as well. There you have it, Cloud Cache running in Windows Virtual Desktop. The final part of this presentation is to cover off MSIX app attach options which are available to you when designing a disaster recovery solution. MSIX is a new packaging format that offers many features aimed to improving the packaging experience for all Windows applications. MSIX app attach is the way to deliver MSIX applications to both physical and virtual machines. However, MSIX app attach is different from a regular MSIX because it is in an expanded state, an unzipped state, on a virtual disk or a SIM image, known as an MSIX image. What does MSIX app attach do for Windows Virtual Desktop? Well, it creates a separation between the user data, the operating system, and the applications by using MSIX containers. This removes the need for repackaging when delivering applications dynamically, reduces the time it takes for a user to sign in, and reduces infrastructure requirements and costs. So essentially, there's multiple options available to you when using MSIX app attach, and one may be on demand, so if the user wants the application on demand and the application is then staged and registered, or on log on, when the user logs on, the applications appear. So that's great. What we need to do though when we're using MSIX app attach is we need to protect it from an outage, or if we fail over to a second region, then applications going to attach in the second region. So typically, MSIX images are stored on Azure files or Azure NetApp files. We've already covered Azure Site Recovery Replication for the domain controllers and session hosts, and we've also covered Cloud Cache for FSLogix profile containers. What about MSIX app attach? As these applications are read-only, we can script this using Robocopy or Azure Automate. In my example, we're using Azure files in a scheduled task to copy any changed or new files to a secondary location. So MSIX images for MSIX app attach can be stored on the same storage types as FSLogix profile containers. For example, Azure NetApp files, Azure files, storage spaces, or a virtual machine with an attached disk. As you may be wondering, yes, you can use Azure NetApp files replication like you would with FSLogix, and ASR replication for storage spaces and a standard virtual machine with a disk. However, if you're using Azure files, you need to find a way of getting the applications from one region to the other. And in this technical demo I'm about to show, we do this using Robocopy. So in this demo, you're just going to see me run a scheduled task from a Robocopy script I've created, which is going to copy any new or changed applications into the secondary storage. And this has been set up on the scheduled task to run at 5:13 every day. And as you can see as well, it outputs a nice little log file, so you can check to see if anything's failed or there's any issues. There you have it. A nice simple way of getting your MSIX app attach apps between two storage locations. That could be Azure files or standard storage drives. So there's been a lot discussed today, and I wanted to summarize. We discussed RPO and RTO, traditional versus cloud VDI in disaster recovery. What does cloud offer in general? Simplicity of disaster recovery when it comes to Windows Virtual Desktop, reserved instances, networking, virtual machines and Azure Site Recovery, managed identities, shared image galleries, and then FSLogix, profile containers and Cloud Cache. And then to finish up, we've briefly covered MSIX app attach and getting applications from one storage location to another. Just some other kind of key points as well. Regular testing should be carried out. Just because it's all set up doesn't mean it's working. Only fail over 100 virtual machines at one time using ASR. If you need to complete more, try and do them in batches of 100 every 10 minutes. And always ensure that users are logged off session host before carrying out a failover. So again, thank you very much for attending this event and taking the time to watch my presentation. I hope you find it useful. If you need to ask me any questions or require any further information, please feel free to reach out to my Twitter handle, email, or my blog. Again, thank you very much for attending.